You are working with the scores in a population with the population mean equals to 40 and the population standard deviation equals to 8. If you were to add 15 points to every score in the population, what would the new mean and standard deviation be? So it's either going to be that the mean stays at 40 and the population standard deviation stays at 8, so no change, or you're going to have the mean stay the same, but the population standard deviation will go to 23, which is, if you think about it, that's 15 higher than 8, so they're just adding the 15 on. Or perhaps in C and D, it's the population mean that's going to increase by 15 points, and the population standard deviation will either stay the same at 8, or it will also increase by 15 points and end up being 23. Now, what's going to happen here is we're going to go with the case where the population mean increases, but the standard deviation doesn't. Now, this is done without any calculations. This is just this is a matter of understanding a characteristic of the population mean and of the population standard deviation. My mean starts off as being 40, and the population standard deviation starts off as being 8. So why would I add the 15 points to the 40 in order to get a mean equals to 55, but not do anything at all to the standard deviation and just stick with 8? Why doesn't the standard deviation change when the population mean does? Well, in order to explain this, let me give you a much simpler example. Let's say that you every day you make $10 doing some task. So you do a quick job and you get $10. So day 1, you make $10. Day 2, you make $10. Day 3, you make $10. And the fourth and final day, again, you make $10. Now, without doing any calculations, it's easy to see here that your average is going to be $10. On average, you made $10 every day because you, in fact, made exactly $10 every single day. Now, what if you were to make, instead of $10 every day, what if you made $12 every day? Well, again, without calculation, you can see that whatever this value is that you do every single time, if you've increased it from 10 to 12, so you've increased by 2 points every single time, then your average is also going to increase by 2 points. You went from 10, an average of 10, to an average of 12. The average is immediately affected by any changes to all of the individual scores. Now, I chose these sets of scores for a particular reason. Not only do they make it easy to see what the average is going to be, but they also make it easy to see what's going to happen with variation. The first job you were doing, where you're making $10 every single day, how much variation is in your pay from one day to the next? First day you make 10, second day you make the exact same, you make 10, and then the same again, and the same again. So there is no variation. Your standard deviation, if you were to calculate it out for this set of values, would be equals to 0, because standard deviation measures variation. What about in the second set of numbers? Is there any more or less variation here? No, this is the same. You make the same amount every single day from one day to the next, so the variation, if you were to calculate this out using your formulas for sum of squares, and then divide that by n to get your variance, and then finally take the square root. If you were to first of all find your variance, and then take the root of that in order to get your standard deviation, you would again come to the result that the answer is 0. There is no variation here, just like there was no variation here. So even though we added something to every single one of the scores to get from set 1 to set 2, we didn't do anything to the variation. We didn't do anything to the standard deviation. And standard deviation measures variation. So doing the same thing to every score doesn't introduce any variation. It just moves all of the scores together in one group. So our answer is the answer where our measure variation stays the same, but the average is affected by the adjustment that we make to every one of our scores.